Right, here's a typical question which involves exponentials. You're looking at the temperature of a liquid, and it starts off, well, I'll go into what it starts off in a second, but the expression for the temperature is 30 plus 20 e to the minus 0.05 t. So the two variables are temperature, which is big T, and time, little t. You can see obviously you've got this constant and this exponential term that's added on. When you've got e to the minus something, and t is and the variable is positive, that you know that when, okay, we'll talk about t, t starts at 0 and increases, and e to the minus 0.05 t will start off at t is 0. When t is 0, you've got e to the minus 0, so it's going to start, this value is going to start off at 1, and as t increases, e to the minus 0.05 t is going to get smaller and smaller. So what we can say is that at t equals 0, big T will equal 30 plus 20 times e to the minus 0. And as we said before, e to the minus 0 is 1, so T equals 30 plus 20, 50. So that's our initial temperature. And then as T increases, it's going to go down gradually. It says also that's the initial temperature. So that's the temperature at time T equals 0. It says find the initial rate of change of temperature. Well, the initial rate of change, we need to decode these words. Initial means at time t equals 0, and rate of change of anything is d, whatever that variable is, by d small t, i.e. the change that that variable has over time. So to work out dt by dt, we're going to have to differentiate this expression. So if you differentiate 30, that's obviously going to be equal to 0. And then if we differentiate 20 e to the minus 0.05 t, right, when you differentiate an exponential function, you get the differential of that expression at the front, so the differential of minus 0.05 t with respect to t is just minus 0.05 times that exponential function again. You can use the chain rule if you make u minus 0.05 t and then differentiate, well, you get the idea. Anyway, 20 times minus 0.05 is just minus 1, so this becomes minus e to the minus 0.05 t, because obviously that 0 is relevant. So the initial rate of change, t equals 0, dt by dt, will be minus e to the minus 0, which is minus 1. So that's the second part. The third part is to find the time at which the temperature is 40 degrees Celsius. Well, we already know what the equation is, so we just need to solve it. We sub in 40 here into big T and work out what T is. So 40 equals 30 plus 20 e to the minus 0.05 T. Take 30 away from both sides. 10 equals 20 e to the minus 0.05 T. Divide by 10, or divide by 20, 0.5 equals e to the minus 0.05 t. Right, now we've simplified it down as far as we can go, but we've still got t up in the tree, as it were, so we need to log it down. Now we're doing log to the base e, so if we take log to the base e of both sides, sometimes written as ln, we get ln 0.5 equals, and this now becomes minus 0.05 t. So t is going to be ln 0.5 divided by minus 0.05. Ln 0.5 comes out at minus 0.693, which means that our final answer is 13.86 minutes.